Good day everyone. We will discuss about application timeout with multi-subnet always on availability group in this video. Let's get started. I'll be using this particular environment for this video. This configuration has a Windows cluster called JBS Wiki CLUST. I have an availability group called JBS AG that has got a listener configured, namely JBS APP. And I have a database called JBS Wiki added to this particular availability group, JBS AG. So this availability group has got three replicas, JBS AG1, JBS AG2, and JBS AG3. JBS AG1 and JBS AG2 is on the primary data center, which is East US, and JBS AG3 is on the secondary data center, which is Korea Central. And what you can see here is like all these replicas are configured using an synchronous commit. Yep. So JBS AG1, JBS AG2, and JBS AG3, all these are configured using an synchronous commit mode. JBS AG1 and JBS AG2, as far as the primary data center is concerned, has got a separate subnet, and JBS AG3 is hosted on the secondary data center DR, which has got its own subnet. So it's going to be a completely different subnet as far as East US and Korea Central is concerned. So now what we'll do is like, let's get into the server. And then let's first look at the always on availability group configuration. So right now JBS AG1 is the primary replica. So let's look at that. And then let's look at the dashboard here. So if you see here, JBS AG1, AG2, and AG3 are three replicas of this particular availability group. JBS AG1 is the primary, and JBS AG2 and JBS AG3 are the secondary. And if you can see the availability mode, all these three are configured, all these three replicas are configured as synchronous commit. I'm not going to discuss about best practices like we need to go for an asynchronous as far as JBS AG3 is concerned because it is geographically separated. Just for this particular video, we are concentrating on application timeout when you have multi-subnet IP address configuration as far as listener is concerned. And for that thing, we are having these three replicas, and the availability mode is configured as synchronous. So right now I'm able to see that all the databases, all the three replicas in the databases are all synchronized. So now what I'm going to do is like I will show you the configuration as far as JBS AG availability group is concerned. As indicated earlier, we are using this cluster JBS Wiki cluster, and the role is JBS AG, which is same as our availability group. And then now if you look at the listener here, which is JBS APP, what we are able to see is like we have two IP addresses. Yeah, 172.20.1.20 is basically for East US, and 192.168.1.20 is basically for the Korea Central location. Now we know that JBS AG1 is the primary, which is in East US. So that's the reason we are seeing that this particular IP address 172.20.1.20 is active. As soon as we do a failover from JBS AG1, which is the owner node right now, to JBS AG3, we'll not do it from the cluster manager, we'll do it from the SSMS. As soon as we fail over from JBS AG1 to JBS AG3, what will happen is like the IP address 172.20.1.20 basically becomes offline, and IP address resource 192.168.1.20 will become active. I will show that shortly, but as of now, this is the concept as far as multi-subnet failover is concerned. So now what I will do now is like I will initiate a failover. Yep, and what I'll do is like we will verify different things. We will check if the IP address resources basically goes for a change after we do an failover from JBS AG1 to JBS AG3, and then we will pick it from there. So now I will go to the always on availability group here. The preferred method is basically to perform the failover from the secondary where you want to failover to. If you do it from the primary, then what will happen is like it will request you to connect to the replicas, and you need to do some extra work. And also the preferred method is to perform the failover from the secondary server, from which will become the primary after the failover. So I just started the failover, so we can see that everything is okay. This is the reason I have kept the availability mode as synchronous. I don't want it to be in asynchronous, and then I don't want to see the reason like there is a data loss. So that's the reason I've put it as synchronous. Since it is a testing server, it's a demo server, I'm doing all these things. But if it is going to be production, you guys will do it as per your requirement. So let's click on next, and then let me perform the failover. So the failover is basically happening from JBS AG1 to JBS AG3 server. So let's wait for the failover to complete. It is completed now. Now let's look at the failover cluster manager. So now if you see here, the owner node is JBS AG3. As advised earlier, what I'm able to see that as soon as we came to, that is the availability group came to JBS AG3, we can see that the IP address 172.20.1.20 is offline, and then the IP address related to Korea Central is online, which is 192.168.1. So this is a subnet here. You just right click and then click on properties, and then you will see that for this particular IP address resource, the subnet is 192.168.1.0 range. So that's the subnet. If you look at it, this is the subnet that we are using. And then we have these two, that this one is for East US and this one is for Korea Central. So now what we'll do is like, let's try a connection to JBS APP and then see what happens. Now this is kind of a real world scenario that we just performed the failover from primary to DR, and DR has got a different subnet. Let's see what happens when you try connect to the listener. Let's consider the application is trying to connect to the listener and then see what happens. In our case, the application would be SQL Server. Yep. Let's connect to some other server. In my case, I will connect to JBS AG3. And then what I'll do is like I will try to connect to JBS APP, which is your listener. We just did a failover from JBS AG1 to JBS AG3. Let's try a connection here. It's taking some time. Maybe like we are on Korea Central, so it's taking time. Let's wait for a couple of more seconds. It is still running. What I'll do is like I will pause the video now, and then I will resume it once it connects or errors out. Okay, I'm resuming the video now. We are able to see that we are getting this particular error here. Yep. So now what I'm going to do next is like I'm going to ping this host name and then see what IP address we are going to see. Okay, so what we'll do is like let's try pinging this host name, CMT ping JBS APP. Okay, so let me ping the listener IP address, and what I'm seeing is like I just pinged the listener host name, and what I'm seeing is like it is still pointing to the IP address that is for East US. It should have pointed to the IP address which is meant for Korea Central, which starts with 192, but it is still pointing to the one that is present in East US. So if you want to confirm that, go to the server JBS AG1 where you have the cluster administrator. If you see here, we just failed over from JBS AG1 to JBS AG3. As soon as we failed over, this IP address took over, but still when you ping this IP address, that is when you ping the host name JBS APP, this is the IP for the listener, this is the host name for the listener, it is still pointing to this particular IP address. So So this is the reason why the application, when trying to connect to this host name, is basically pointing to a wrong IP address, and then that is the reason it is not able to connect to the listener. So now let's discuss like why we are having this particular issue per se. Okay, so but this one is in this particular problem can happen for anyone, and as far as the failover is completed and the application is trying to connect to the application is trying to connect to the listener, this is like an very likable issue that anyone can face. So let's first discuss like what's this issue is. So we know that the availability group listener is basically configured with an IP address from each defined subnet. We know that, right? So we looked at this one. So we are seeing like for East to West, this is the subnet, and for Korea Central, this is the subnet. So this means that the availability group listener will have an IP address of 172.20.1.20 when it resides in East US, that is the primary data center. And then this IP address 192.168.1.20 will become active or online when we fail over or when it resides on the secondary data center, which is basically your Korea Central region. Yeah. So client operating system queries the DNS server to resolve the listener name to IP address, and DNS will return two IP address in this environment with one IP address that the subnet currently hosting AG primary replica will be online, and other IP address that the subnet hosting secondary replica that is basically offline. So when the client operating system basically tries to resolve the listener name to IP address, it basically queries the DNS, and then the DNS basically returns two IP address in this scenario. That is these two things: 192.168.1.20 and then 172.20.1.20. One will be active and one will be like offline. So these two IP addresses basically sent to the operating system by the DNS. Okay, and now the client application using the always on listener can have connectivity issues while connecting to it, because we basically know like out of these two IP addresses only one is active and the another one is like basically kind of offline, so it is going to be inactive. So now the application basically tries all the IP address, in our case both these two IP address one by one. That's the most important thing here. It is not going to connect at a time. It is basically going to get these two IP address from the operating system. Application will basically get these two IP address from the operating system, and then it tries the connection one by one and connects to the one that is basically online. Yeah. Since this particular thing is done serially, there is high possibility that the application reaches its timeout value and then the connection terminates with a timeout error. So this is what is happening in our case. So in case if the first IP address that comes is online, then application will be able to connect to it. But let's say like intermittently it gets when it is trying to connect serially and the first IP address that it is trying to connect is offline, then it basically errors out, and that's the reason we get this an intermittent issue. It is not going to be always a problem. It is going to be like when you try it, sometimes it goes through and sometimes it basically errors out. And the explanation is that since it is doing serially one by one the application, there is possibility it might work and sometimes it might not work, and that is where it becomes a little tricky. Now what you'll do is like we will think about fixes here. So what we will do is like the first thing, the easiest fix that can be done is like we basically have to talk to the application team and then check if they can add a switch called multi-subnet failover parameter to true in their application connection string. So this is the first thing, and if we can do this, then there is a full stop here, no need to do anything else. So the first thing is like as soon as we know like there is an error that is happening like this in your multi-subnet always on environment, first thing that we do is like we will talk to your application team and then ask if their connection string will be able to use this parameter called multi-subnet failover, and you need to put it as a true in the application connection string. And if the application team basically tells like, yeah, their connection string supports this parameter multi-subnet failover, then I think like that should be the great solution here. So when this multi-subnet failover parameter in your application connection string is set to true, and assume it is going to work, then what happens is like the application basically connects or tries all AG listener IP address in parallel. So previously, what happens is like it is going to do serially one by one, and you might hit your connection timeout parameter, and then you get into this problem. But as soon as you add this parameter, multi-subnet failover is equal to true, what happens is like the application basically tries all the listener IP address in parallel, and this will basically avoid the connection timeout caused when trying serially. So now let's consider if multi-subnet failover parameter is not supported. So the application team is basically telling like their application, the ODBC or OLADB, whatever they are using as far as their application is concerned, doesn't support this particular parameter, multi-subnet failover is equal to true. That is when we will have challenges, because what happens is like now that we are not able to do this, so now what we need to do is like we need to do certain changes on the environment as far as all the replicas are concerned. So if adding multi-subnet failover parameter to the application connection string is not possible, then basically what we need to do first is like we basically have to set register all providers IP value to 0. So that's the one that we need to basically do. Like we have something called register all providers IP, as well as the cluster parameter is a cluster parameter, not the application parameter, and that needs to be set to 0. Okay, and now when register all providers IP is set to 0, what happens is like only the active listener IP address is registered in the DNS. So when set to 1, all of the IP address that the listener is dependent on is registered with the DNS. So the default is basically register all providers IPs by default is set to 1. And what we need to do in this case is like we basically have to set it to 0, and which will ensure like once we set it to 0, we will ensure that only the active listener IP address is registered in the DNS. And that way, we will be, when the application queries your listener name, it will get only the active IP address. So that's how it can help. That's the first thing that we need to do. Basically, like set register all providers IP to 0. So what we'll do now is like we will basically set register all IP parameter for the listener JBS APP to 0. So now what we'll do is like let's first look at the PowerShell, and then let's query the required resources. Let's basically query the resource, and then we will see what do we have as far as the cluster parameters are concerned. So I'm going to use this command, get cluster resource. So I'm very much interested on my listener resource. There are possibilities we might have a different name as far as the listener is concerned. So in my case, I'm able to see that network name JBS APP is there. So now what I'm going to do is like I'm going to check for the values, the parameter values set for the listener JBS APP. So what I'll do is like I will replace this here with the listener name, which is the network name resource type from the above output. So if you see here, this is our listener name. So I'm just putting that, and I'm going to look at the cluster parameter for this. I'm going to first look at register all IP. That's the one that I'm going to look at. So we have this register all providers IP. So we have it. So we can see that it is set to 1. The value is 1 here. Yep. So now what I'm going to do is like I'm going to change that particular value to 0. So we know that we are currently primary as far as JBS AG3 is concerned. So what I'll do is like I will go there and then open a PowerShell there. And then I will do the things from the start. So what I'm going to do first one, I'm going to get the cluster resource. Let's press tab here. Yes, I have it. So let's look at the resources we have because JBS AG3 is the primary, yeah. So JBS APP is there. So now what I'm going to do is like I'm going to get the cluster parameters for the listener. So let me go ahead and do that. JBS APP. And then I'm going to look for this register all providers IP parameter. And now what I'm seeing, register all providers IP is 1, which is the default value. So now what I'm going to do is like I'm going to basically change that to 0. Yeah. So that way I will have only the active IP registered with the DNS. So now get cluster resource name is your listener name, and then what I'll do is like I will put set cluster parameters, and then let me take this one, which is register all IP. Oops. Let's remove that. So set cluster parameter, and then I'll use this, and then 0. So now what I'm going to do is like I'm going to change this register all providers IP for the listener name JBS APP to 0. Yep, so now if you see here, it basically tells like the properties were stored, but not all changes will take effect until this particular resource is taken offline and then online. So now what I'm going to do, I'm going to open the cluster manager here. And then what I'll do is like I will offline and then online you can basically do a failover, but in my case I'm not going to do a failover. What I'll do is like I will just offline it and then online it. That's what I'm going to do. So we have this here. Let's go to the listener here, click on it, go to the resources. So this is the one. So what I'm going to do is like I'm going to do a take offline. It is down now. So what I'll do is like I will bring it online again. Yep, so everything is good here. Okay, all good. It is better we do an failover from one place to another place. That is something that you can do, or you can do this way. Yep, so now this is done. So there will be a downtime of like a couple of seconds depending on the number of database and things like that. So now what we'll do is like let's go to JBS AG1. And then now we have seen that register all IP is set to 1 here. So let's see after we restarted, what is the value? That is, we made the listener resource online and offline. So if you see here, as soon as we did it on the primary, it is getting propagated to the secondaries also. So no actions as far as any other nodes are concerned. So this is one thing that we have completed as far as register all providers IP parameter is concerned. The next next parameter that we are going to talk about is a parameter called host record TTL. So this parameter, that is host record TTL, should be set with a value maybe like 60 to 300 from the default value of 1200. So now let's go to the primary JBS AG3, and then let's query that a listener resource, and then let's look at the cluster parameter. So now we see that register all providers IP is set to 0, and host TTL, host record TTL is basically set to 1200. So 1200, it is seconds, yeah. So 1200 seconds is like divided by 60, which is basically 20 minutes, okay. So what happens is like this host record TTL parameter decides how long in seconds the client operating system will query the DNS for the current IP address. So reducing this value can have an adverse effect on your DNS server if there are several servers connecting to DNS to resolve the listener IP address. Hence, it is advised to set to 60 to 300. To be frank, like let's consider you have thousands and thousands of database servers with always on availability group configured, and then you have, in case if you change this host TTL record, host record TTL value to say from 20 minutes, that is 1,200 seconds to say 60 seconds. What happens is like all these thousand servers will at the same time like frequently put load on the DNS requesting for the IP address as far as the listener is concerned. That can put some sort of load. But in my case, like I have done that on several servers. I have set it to 60 seconds, and to be frank, I've never seen any issues. But yeah, this is something that you need to keep in mind before changing that. If you do it, there can be an impact when you have too many servers that are all trying to get the same information so frequently. It will be an impact. Like whenever you change some values as far as recommendations, so you have a default recommended value, and whenever you try to change that, always there will be some sort of an side effects. But yeah, in my case, it's not a big of a deal because I don't have that many servers, and even with the number of servers that I have, when I set the host record TTL to 60 seconds, at least I did not see any kind of big impact. So now what I'm going to do is like I'm going to do same thing where now we know like a host record TTL is set to 1,200. So what I'm going to do is like I'm going to copy that and then press enter, and then I'm going to change that to 60. Okay. Again, I will just update like what is host record TTLS. It is basically like this particular parameter decides how long in seconds the client operating system will query the DNS for the current IP address. So if it is set to 60 seconds, then what will happen is like every 60 seconds, the client operating system will query the DNS server and then request for the IP address of that. And that way, what happens is like you will be having the recent IP address. So at max, like 60 seconds, within 16 seconds, you will be able to get back the information just in case if there is a failover. Okay. So now let's look at the value again, and then see what is it set to, collect cluster parameter, and then I can see that host record TTL is 60. So now what I'm going to do is like this time what I'll do, I will do a failover so that I will have to do the testing again, right? So what I'll do is like I'll go to JBS AG1 and then I will do a failover. I'm just doing this failover just to make sure like whatever changes that I've done is taking effect. In reality, when you're doing it on the production, I would recommend you doing that both these changes at the same time and then perform a failover to take effect. I won't be doing first on register all providers IP, do the restart, and then again do it for host record TTL and then do a restart. I won't be doing it since I'm basically demoing it here. I'm doing it one by one, but in reality, production server, we will basically be doing it both at the same time. That is, change register all providers IP and then host record TTL to whatever value is required, and then we basically perform a failover to have this take effect. So let's wait for the failover to complete, and then the failover is completed. So now what we'll do is like let's go back to this one, and then let's go back to JBS AG3, and then let's look for, let's look at the cluster parameters. So what I'm seeing is like register all provider is set to 0 and host TTL record is set, host record TTL is set to 60. Let's do the same thing for JBS AG1 as well. Let's do the get cluster parameter, and then I'm able to see that host TTL record is set to 60 and register all providers IP is set to 0. So now what I'll do is like I will try a connection to our listener, JBS APP. It is connecting fine. I don't have any issues as last time. Now what I'll do is like I will try the same thing in JBS AG3 as well. Let's try the connection here. Let's go to the SSMS. We are on JBS AG3. Now when we connect, it is working. So it is able to make the connection, and if you see the listener name, what I'm able to see is like since we have the availability group hosted on JBS AG1, this particular IP address is active. So we don't have an issue here. So now what I'm going to do is like I will do a failover one more time from JBS AG1 to JBS AG3, and then we will try it one more time. Let's do a refresh. The secondary, so let's do a failover here. Click on next. Next, and then do the failover, and then we will check if you're able to connect. Okay, the failover is happening currently. Yep, the failover is completed. So this has become primary. Now from JBS AG1, let's connect to the listener. It is working, and now I look at the cluster configuration, that is the cluster manager. I'm able to see like this IP address has gone offline and this has become online. And now I'm able to connect here. Let's do the same thing on JBS AG3 as well. Let's disconnect, connect it one more time, and it is working. That's it for this video. Thanks for watching. Have a great day. Jai Hind.